Good morning, children. Today we are going to discuss the chapter 8, that is motion. In this chapter of physics, we are going to discuss today the following topics: rest and motion first. Second one is the description of motion. Third one is distance and displacement. So let's move to the next slide. In this picture, if you see that if the boy starts moving in any direction, then it means we can see that the boy is moving in any direction, means the boy is going to change its going to change his position with respect to the stationary object. So when any object is changing its position with respect to the stationary object at a given time, that object is said to be in the state of motion. So this is all about the definitions of the rest and motion. Now let us discuss the rest and motion are the related terms. How do we find out the rest and the motions are associated with each other? So let us understand this with the help of example. For example, the passengers are inside the moving bus. So bus along with the passengers are moving in the forward direction, but they find the roadside trees are moving in the backward direction. Now if a person who is standing roadside is observing them, for that person he feels that the bus and the passengers are moving in the forward direction. But if you consider a passenger inside the bus finds his fellow passenger is at the state of rest. So this example indicates that the rest and motion are associated with each other. So let's understand it again with the help of this picture. So the buses along with the passengers are moving in the forward direction, and outside the people who are standing outside, they find the bus is moving in the forward direction, but the passengers inside the bus, they find the people outside they are moving in the backward direction. But if you compare the two passengers inside the bus, any one passenger finds his fellow passengers in the bus is at the state of rest. So this picture indicates that how that is the rest and the motion are associated with each other. Next is describing motion. In order to describe the motion of the object, we need to specify the reference point, and we need to specify the location of the object. For that we need a origin. We need a reference point with respect to which we can see that how the object is changing its position. So let us consider an example. For example, there is a school in a village, and the school is 2 kilometers north of the railway station. So here the railway station indicates your reference point, and with respect to the reference point you can find out the school is 2 kilometers away from the railway station. So in order to locate the position of the object, the first thing we need to understand, we need to specify the reference point with respect to the position of the object, and this reference point gives us the location of the object, gives us the positions of the object. So in order to find out the position of the object, we can say we need a reference point, and this reference point is also called as the origin. In this way we can describe the motion of the object. Now focus on this diagram. Here the reference point in this diagram is considered as origin, and suppose the object starts moving from the reference point, or which is called the origin, that is O. So if object moves from O to C, in this case the distance which this object covers is 25 km towards C. And if you see the track again, if object moves from C to B, then B to A, then in this entire journey the object covers from O to A, the object covers 60 kilometer. So if you look at this distance, it is a distance, means it is the path length, total path length which this object covers is called the distance covered by the object. And consider the another path where the object moves from O to A. In this situation object is going to cover 60 kilometer. If object again comes back from O to A, in this case the object is going to cover 60 plus another 60, that becomes total 120 kilometer. This is all about the distance. But if you consider the same example, for example, if the object moves from O to A, it covers 60 km, and if again comes back from A to O, then it covers, in case of displacement, it covers zero displacement, because the displacement is the smallest distance which depends on the initial and the final position of the object. So here the initial position of the object is O, final position of the object is again O, for his journey O to A and A to O. So it's very, very important that the displacement becomes 0 when the initial and the final position of the object coincide or they remain at the same point. That shows that the displacement is 0. What the distance depends on the path length. In that situation, the distance has the value 120 kilometer. So this is the distance and the displacement. Now again, let us understand the concept of the distance and displacement with the help of this diagram. For example, object starts from O to A, and that is 5 kilometer, A to B again 5 kilometer, B to C 10 kilometer, and the half of the B, if you consider the point N is the midpoint of the BC, then the NC is 5 kilometer. So in this case, if you're going to calculate the total distance, so just add all these paths, that is 5 kilometer plus 5 kilometer plus 10 kilometers. So the total distance which this object covers is 20 kilometer. Now let us calculate for the same diagram the displacement which this object covers. That is, displacement again depends on the initial position, that is O, and the final position, that is C, but it does not depend on the paths O, A, B, C. It depends on O and C. So let's find out join the position O and C with the help of the arrow from O to C. This vector gives the value of the displacement, so we can easily find out the displacement by using the Pythagoras theorem. So if you use the Pythagoras theorem, the OC square is equal to NC square plus the NO square. So here NO is 5 kilometer, NC is half of BC, that is also 5 kilometer. So calculate this, it comes out to be square root 5 square plus 5 square. So total displacement which the object covers is 5 square root 2 kilometer. Now let's differentiate between the distance and the displacement. Distance is a scalar quantity, whereas the displacement is a vector quantity. Scalar quantity is one which has the magnitude, and the displacement vector quantity. So vector quantity is a quantity which has the magnitude as well as the direction. Both the distance and the displacements have the same units. The distance is equal to or is less than that of the distance, but the distance is always greater than the displacement. Displacement may be 0, may be positive or negative, but the distance is 0 or positive. And in between the initial and the final position, we can have any value of the distance, where the displacement has only the one value. So that's all about the distance and the displacement difference. Now this is the numerical which is based on to calculate the distance and the displacement along the circular path. So let us consider the first case. Object is moving along the circular path and the circle has radius r. So calculate the distance when object completes half circle and when the object completes one full circle. So let's say the O is the center of the circle, r is the radius of the circle. So when object completes half circle, that is means the A is the reference point and B is the final position of the object. So first let's calculate the distance and the displacement for the track A to B. So if you see that the distance A to B is the half of the circumference, that is half into 2 pi r, so that the distance becomes equal to pi r. What the displacement depends on the initial position, that is A, and the final position, that is B. So A to B, irrespective of the path, you join A to B position, it goes along the diameter and the diameter is equal to 2r. So in this situation the displacement is 2r. The second is when object completes one full round, for that the distance is circumference, that is 2 pi r, and when object completes one full round means object starts moving from initial position, after taking full round again it comes back to the A position. In this situation both the initial and the final position are at the common point A, that makes the displacement 0 as the final position meets the initial position. Next is what do you mean by the uniform motion and the non-uniform motion. Uniform motion means when object covers equal distances in equal intervals of time, however small the time interval may be, that is called as uniform motion. Let us understand it with the help of example. object covers 50 kilometer in first hour, in the another 50 kilometer in the second hour, another 50 kilometer in the third hour, it means that in each hour the object is going to cover 50 kilometer. This indicates that the equal distances in equal intervals of time, so that motion is uniform motion. When object moves in the uneven road, or the person is jogging in a park, or a bus is moving in a crowded street, or any person is moving in that the crowded street, that are the examples of the non-uniform motion. Non-uniform motion means when the object covers unequal distances in equal intervals of time. So that's all about today. So please make note of it, write all the points in your notebook and learn them. Thank you.